Greetings. So this is a quick demo and walkthrough of what the the G-naira is all about. So this is a kind of overview of the project. So the G-naira is a digital currency that uses the ERC20 token standard. So it's built using the ERC20 token standard. So the contract has an account we call the governors. So the governor contract or the governor account has the sole responsibility, or he's the only guy that has the right to mint new token currency. He's also the one that has the right to burn token currency. And he also has the right to blacklist addresses and prevent them from sending or receiving token. Just the same way we have in our traditional finance, whereby the governor of the central bank has the overall say. So the same thing is what we are applying here. But now we are building a digital currency, not just an ordinary currency. So I'm going to, okay, this is the README of this report. So I've already, the README contains more info, more guides on how to use the project, maybe for those that would like to contribute to the project. And so this token was deployed with a total supply of 100 million and a maximum supply of 1 billion. So let me just walk you through the code in REMI so that you actually understand what is going on, because I want to explain how it works on the REMI's ID and also how it works on the using React. That is when you now integrate it with front end, you now have a dApp. So we have both the dApp for it and the REMI's code for it. So, but first of all, I will explain with REMI's. Then after REMI's, I will explain with React. All right. So this is the code on Remix. So let me just walk you through the contracts. Let me walk you through the contracts. So this safe mask is a library that helps you to control underflows and overflow. So here we have the state variables. So one of the state variables we have here is the maximum supply, which is 1 billion. So what this thing simply means is that as long as this contract remains, you can't have a total supply more than 1 billion. So that means you can't mint more than 1 billion token. So the maximum we have in circulation is 1 billion. So that is the essence of maximum supply. And if you watch, it has a keyword constant. Having a keyword constant means that you cannot change it. Once you deploy this contract, you can't change it. Then we have the total supply is 100 million. I will show you the total supply. Then we have the governor contract, so which have the sole responsibility of minting token, burning token, and also blacklisting addresses. Now we have an array of signers. Now this array of signers, there are signatories. There are people that will be able to sign in a function I'm going to explain later. We call the multi-sig. It's just like in our traditional finance, you have a joint account. You know, when you have a joint account, for you to actually withdraw, maybe one or two signatories to the account must sign. So that is the same thing you want to apply here. So you want to secure the minting of token, the minting and burning of tokens, to make sure that before you mint, not only you, the governor, can sign, another person who is the signatory to the contract we approve it. So without sufficient approval, you can't be able to mint or burn the token. So these things are these are mappings. So we have modifiers. So modifiers are just like security checks. So they help to make sure that the condition is fulfilled before the transaction is executed. Like for instance, here we have sufficient balance. So it will make sure that the amount a user is requesting for, the amount a user wants to use, must be less than or equal to the balance. So that you don't spend more than what you don't have. Yes, so whatever you want to spend, you must have lesser of it. So we still have a modifier to validate address. This is just to check and make sure that the address is correct, so that you not send a token to a zero address. So before you be able to transfer to someone, before you can be able to mint to an address, this modifier must first of all be called to confirm that the address is not a zero address. Now, if it is a zero address, it's going to revert the transaction with an invalid message, that is, it's an invalid address that is telling you that the address you provided is not valid. Then you have to check it. So we have modifier for not blacklisted, so which we actually check if an account or if an address is blacklisted or not blacklisted. So before you can be able to send money to an address, before you can be able to receive money in an address, the address must not be blacklisted. Now, if your account is blacklisted or if your address is frozen, you can't be able to receive payment. You can't be able to send payments. So the same thing is what we want to apply here. So before you be able to transfer or mint to an address, this modifier will be called up to check whether if the address is blacklisted or not. Now we now have the governor, so which is like the big guy in the contract. So he has the highest preferential, he has the highest authority. So he's the one that can be able to assign rules to people. I will show you some rules we can assign in the contract. So we have the total supply, which is our initial supply, which is 100 million. So these things are just contracts initialization. So we've defined state variables up here. So some of these state variables we define up here. Now coming to the constructor, we are trying to initialize them. So setting them to the blockchain state so that they'll be stored in these variables. So these state variables, yes, so as we are initializing it, they are getting stored in the state variable. Now we have total supply. So this is the function. So when this function is called, what it does is that it returns the total supply of the coin or the total supply of the token currency. Now the balance of returns the address of an account. So once you put an account number and call this balance of, it will return you the balance of that account. Now the transfer will allow you to send money to someone. So you put the recipient, the address of the receiver and the amount. Now, before that can be done, first of all, it has to check that you have sufficient balance. It has to validate the address and it has to make sure that you are not blacklisted. So these are these modifiers I defined up here. So we have function to approve. So you can approve a spender, allow someone to spend on your behalf and the rest. So because of time, I will just go through the, okay. I will not be going through all the codes in the contract here in the remix. Then when I'll be explaining with React, I will go more in depth in it. Now we have the mint token function. So what this allows is, it allows you to mint the token currency. So before you can be able to mint, you have to provide an address. And again, the amount you mint. And again, before you can be able to mint to this address, it has to check and be sure that this address is not blacklisted. Now, if this address is blacklisted, you can't mint to it. And again, it's only the governor that can be able to perform this action. So if you are not the governor, you can't do this action. So if you are not the governor, you don't have right to do this. So once you try to mint, it tell you are not the governor. And again, it's also check and make sure that you are not minting to a zero address. So that means the address you are sending it is valid. Then we have the function to burn token currency. So once you burn a token currency, so what you are trying to do, you are reducing the number of tokens in circulation. So before you can be able to burn, you need to specify the address you are burning the token from. That is the account you are burning the token from and the amount. Then before you are actually burn, this function will check that you have sufficient balance. So that is the work of this modifier we define here. So if you cannot burn more than, let's say that if you have $10 in your account, you can't burn a token worth of $100. So that is the function of this sufficient balance. Is a modifier I defined up here. Sufficient balance. All right, so we have this set governor. So what this particular function does is to a kind of transfer ownership. Now, once I deploy this contract, I'm the owner of the contract, but I can transfer the ownership to another person. Maybe I now want to give it to another person. So from this set governor, I'll put the address I want to make the governor. So anybody I made the governor will not be able to mint and can be able to burn. So all the rights that the governor has, this new address will have it. So this for the multi-signature wallet to actually set various signatories for minting and burning. So you pass in an array of addresses, maybe 3 or 4 addresses. Then you also specify the required number of confirmation, the required number of signatories that you have before you can actually confirm the transaction. Then we have the multi-segment. So this for minting of the token by multi-sig. So we also have the multi-sig burn for burning of the token by multi-sig burn. So this is a quick overview of the smart contract. Now let me deploy this contract on the Remis and show you some of these things I just explained so that you actually understand how it works. So I will deploy the contracts. So from here now, this is green telling you that the deployment is successful. So I can open this contract. Now, this is the account that deployed the contract. This 0S5B is the account that deployed the contract. Now, I want to switch to another account. Now, this account that deployed this contract is the governor. So this account that deployed this contract is the governor. So I want to change to another account. Now, since I changed it to this account, let me copy the address. Now, since we say that it is only the governor that has right to do most of the functions, so let's confirm. Now, first of all, I want to add a bonus. So I want to add another address for him or her to be able to burn. So I will click transact. Sorry, you see that it gives us an error. You see the red. It gives us a red check here. So telling you that it tells you transaction failed. So you are not the governor, so you can't do that. Now, let me try to blacklist an address. Let me blacklist an address. Now, if you see the message here, because this transaction reverted. Now, see the reason for the revert. If you read the reason for the revert, it tells you that you are not the governor. So it's telling you that you are not the governor of this contract. You are not the owner of this contract. So it's only the governor that has the rights to do this. Okay, so let me see on blacklist a user. Okay, that's blacklist. Let me burn token. Okay, let me say I want to burn 3,000. Now I have $0, but I want to burn a token of 300,000. Or I want to burn a token of $300,000. So it's telling me sufficient balance. So that is to tell you, before you can actually burn a token, you must have more than what you want to burn. So that's sufficient modifier we define in the contract. Take care of this guy. So let me mint. All right. Okay, let me say I want to mint. All right. Now I want to mint a token. Now it tells me that I am not the governor. So this transaction was reverted. If you look, you see the S icon. So it tells you you are not the governor. So only the governor can mint. Then, all right. So let's just go and get okay. This is the maximum supply of the token. This is the name of the token. This is the owner of the token. That's 0S5B. Now this is the symbol. All right. This is the total supply. Yeah, so let me now. I want to switch back to the governor and perform that transaction again for you to confirm. I want to check if an address is blacklisted. So for now, it's false because I'm not the governor yet. Okay, let me balance of an address. So currently the balance of this address is 0. So remember, we wanted to burn. So since we have 0, we can't burn. But once I change to the governor contract and mint to this address, I can be able to burn. All right, so I want to switch to the governor. So I'm now in the governor account. So let me burn. You see, the transaction was successful. He gave you a green mark telling you successful. Okay, so before I burn, let me first of all mint. So transaction is successful. So you can read the log if you read the log, you get more info. You see gNaira.token.me. So it's successful. Transaction mined and executed succeed. So the start is succeed. So telling you that it's successful. So now since I've minted this amount, so let me go and burn. I've minted more than, so let me burn. So it's successful. So it's only the governor that is able to do this. And if you read the status, it's successful. All right. So as a governor, let me blacklist an address. Let me blacklist an address. So I blacklist an address. Sorry, let me. All right. Let me copy another address. All right, so I want to blacklist. Tells me I'm not the governor. So let me switch to the governor contract. Okay, so the governor now is able to blacklist this address. So as the governor, I was able to blacklist this address. So if you check the status, execution succeed. Now, since I blacklisted this address, let me confirm if actually this address was blacklisted. So let me call the blacklist function. So if this address is actually blacklisted, now it's false by default. So, but once you blacklist it and call this function, it return to true. Sorry, I think I'm on the wrong address. Let me copy the right address. All right, so all right, so you see it turned to true. So this tells you that Yeah, actually that this address was blacklisted. Now I want to unblacklist an address. So if I click on blacklist, it's going to unblacklist this address. So it's successful. How do we know that the unblacklist was successful? So let's look at the getter function for unblacklist. Okay. So since I've unblacklisted this address now, if I check blacklisted again, it returns to false. See, so that tells you that, all right, this address has actually been unblacklisted. So this is a quick demo that shows you how only the governor of the contract can be able to amend. Only the governor of the contract can be able to burn token, and only the governor of the contract can be able to blacklist. Now, another third party can be able to do this when the governor has assigned a role to him or her. Also, going through multi-sig, we can be able to secure minting and burn of tokens. So before you mint or burn, you don't just wake up and mint and burn because you are the governor. Before you mint or burn, you need to consult other people who have rights to the contract. So that means before you mint or burn, another signatory must confirm. So if the number of signatories are not met, you can't mint or burn. So let me set a multi-sig. But before I do that, let me set up an array of addresses. Let me set up an array of addresses. The addresses are used for the multi-sig. So I want to use these last 3 addresses for the multi-sig. All right. So this is the first address. That is the first signer. Now this is the second signer. So you can specify any number of signer you want. Yeah, but I just want to have 3 signers, but with 2 validations. So only 2. Once I have 2 proofs, then the action can be performed. All right. So that is for multi-signal. So I want to set multi-signatory. So if you look here, it's expecting an array of addresses. So that's why I put them inside an array. So now it asks me what is the required number of signatories. Now, since I'm having 3 addresses in the array, so I want to use 2 signatories. So once 2 confirms, yeah, once I have 2 witnesses, the transaction can be performed. So if I don't have up to that 2 witnesses, I can't perform the transaction. So I want to set multi-sig now. Now this transaction will be reverted because I'm not calling it from the governor contract. So let me go back and switch to the governor contract. So it's not the governor contract that will be able to set the multi-sig. Then once the governor contract set the multi-sig, then for you now to mint or burn, you now need confirmation from the signatories in the account before you can do that. So set multi-sig. So I've set multi-sig. Let me just expand this guy. So status, transaction, mine, and execution sources. So it tells you that, okay, these addresses, I've set them as signers to this contract. So if I want to mint, where are those functions? So if I want to mint by multi-sig, or if I want to burn by multi-sig, I have to, there is other signatories must confirm before I can do that. But I will show you that more when I when I go to the React, so this video is becoming lengthy. Let me just cut it. So this is a quick overview of how the G-naira contract works on the Remix interface. So in the next video, I'll be explaining how it works on using React. So we already have a dApp, we already have a decentralized application I built for it. So I will now explain to you how you can use the dApp, how it works on the dApp. So all those, everything we did there, we can be able to now do it on this dApp.